Forget megastones, forget trainers, forget the bond between a human and their Pokémon unlocking some hidden power. Real evolution doesn't care about any of that. Real evolution only cares about one thing: survive or die. What happens when a creature built entirely around fire gets trapped in a place that wants to kill every flame inside its body? What happens when an animal designed for freezing water gets pushed into a volcanic hellscape where the ocean itself is boiling? They don't die, they become something else entirely. This is thermoevolution, and it's backed by real biology. Inside every living cell on Earth, yours, mine, a lizard's, a deep-sea fish's, there are proteins called heat shock proteins, HSPs. They've existed for over 3 billion years. Their job is terrifying in its simplicity. When your body is pushed past its thermal limit, HSPs flood the system like an emergency response team. They stabilize proteins that are collapsing. They buy time. They signal the rest of the cell something is critically wrong. Change or die. But here's where it gets interesting. In some organisms, that stress signal doesn't just keep you alive, it unlocks something. Through a process called epigenetic reprogramming, extreme thermal stress can physically switch on genes that have been completely silent for the organism's entire lifetime. Genes encoding different body plans, different tissue structures, different physiological systems entirely. This isn't mutation. The DNA doesn't change. Think of it like a locked room in a building you've lived in your whole life. You never knew it existed. The emergency breaks down the door. Scientists call the broader process phenotypic plasticity. One genome, multiple possible bodies. The environment decides which one gets built. Axolotls, normally aquatic their entire lives, when exposed to specific hormonal stress, fully transform into land animals. They grow lungs, restructure their skeleton, lose their gills. Same DNA, different creature. The code was always there. The environment just never forced it to run. Thermoevolution is what happens when a Pokémon hits that threshold. Charizard lives in mountains, volcanic ridges, thin air, extreme heat. The flame on its tail isn't decorative, it's a direct window into its metabolism. The Pokédex is clear. If that flame goes out, Charizard dies. Iceland makes perfect sense as its territory. The island sits on the mid-Atlantic ridge where tectonic plates constantly pull apart and magma rises. Charizard nests near Grímsvötn, one of Iceland's most active volcanoes, buried directly under Vatnajökull, the largest glacier in Europe. Volcanic heat below, thousands of meters of ice above, a perfect thermal boundary. But Vatnajökull is moving. The ice advances. Charizard's volcanic ridge, its thermal anchor, gets swallowed. It doesn't flee. -20, -30 at night. Wind that would kill a human in minutes. For the first 48 hours, Charizard burns harder. Metabolic overdrive. HSPs flooding the system, trying to hold core temperature. But the cold doesn't stop. By day 3, the threshold breaks. The scales thicken and darken. A biological insulation layer trapping radiated heat close to the skin. The underbelly develops dense subcutaneous fat, something no Charizard in a temperate environment ever forms. Blood flow to the wings drops sharply. Less heat lost to extremities. More for the core. The flame changes. Instead of burning outward and venting heat into the air, it redirects inward through a network of newly formed thermal channels in the chest cavity. Charizard stops being a creature that radiates fire. It becomes a creature that contains it, a living furnace, sealed. The body grows denser, lower to the ground. Wings press tight against the body when not in flight. Every energy output becomes calculated. On the glacier, it moves like a dark, armored shape across white ice, hunting seals and fish at glacial melt pools. When it breathes fire, it's a short, pressurized burst, targeted, nothing wasted. The glacier didn't kill it. The glacier made it harder. Lapras is not built for aggression. That's part of what nearly ended its species. Gentle, intelligent enough to understand human speech. It ferries people across cold water without complaint and doesn't fight unless cornered. In the near-freezing waters of the North Pacific, the Bering, the coastline off eastern Russia, it thrives. Thick shell, ice-type biology. Slow, powerful strokes through water that would paralyze anything else. Kamchatka's coast should be ideal. Cold currents, rich in fish, remote. But Kamchatka isn't just cold ocean. It has 30 active volcanoes and is home to the Valley of Geysers, a 6-kilometer stretch of hydrothermal activity where ground temperatures reach 250 degrees Celsius just 500 meters below the surface. A lapras following fish into a coastal bay enters water fed by underwater geothermal vents. The gradient is violent. Surface near freezing, subsurface channels superheated. It dives, and it can't surface fast enough. Thermal shock immediate. Its shell, that heavy gray carapace, normally protects against physical damage. Here, it becomes a trap. The shell conducts heat and transfers it directly to the body underneath. Core temperature spikes. The ice-generating systems, everything that lets lapras freeze water, generate icy breath, regulate its own temperature, they overload, shut down. HSP response fires instantly, but the heat doesn't stop. The shell doesn't crack, it transforms. The blunt knobs across its surface spread and flatten, becoming wide radiating fins. Thin, dense with blood vessels, designed to shed heat into open air. The color shifts from gray to deep rust red as heat-dispersing compounds saturate the tissue. The long neck develops a thermal exchange system in its vasculature. Warm arterial blood running toward the head passes alongside returning venous blood, equalizing temperature before it reaches the brain. The same mechanism Arctic mammals use to prevent freezing, but running in reverse. Now it prevents the brain from cooking, and the ice organs don't die, they adapt. Unable to produce external ice in superheated water, the cellular machinery redirects. Instead of projecting cold outward, lapras uses those same biological systems to cool itself from within, drawing heat away from vital organs and venting it through the shell fins in controlled bursts of steam. It moves slower now in shallow volcanic water, fins always above the surface, grazing near geothermal vents where mineral-rich water fuels its constant thermal demand. This is thermoevolution, not a power-up, not a trainer's gift, a biological response to the most extreme pressure nature can apply. Be what you are, in a place that wants to destroy everything you are. The fire creature learned to seal fire in. The ice creature learned to weaponize heat against itself. Same DNA, completely different animal. If you want to see what happens when we push other Pokémon into other extremes, other impossible places on Earth, subscribe. We're just getting started.